Welcome back to Psychology with Mr. Snyder. I am Mr. Snyder, and today we're going to be talking about hearing and the process of our ears and what it goes through to hear. So let's take a look at our learning targets. Learning targets are to list and explain the characteristics that every sound has, so kind of a mini science review lesson. And we're going to identify the main parts of the ear, main parts that are necessary for a knowledge of psychology. So sound. What is sound? We've already talked about light. Light is electromagnetic energy from the portion of the spectrum that is visible coming into your eye and reflecting off of your retina. But sound is just vibrations of the air around you. You can hear it right now. It's caused by the speakers in your computer moving the air on the way to your ear. Each vibration is called a cycle or a sound wave. And every sound has its own pitch and volume. Those are the two characteristics. Pitch is how high or low a sound is. The pitch depends on the frequency of the sound, and the frequency is the number of cycles per second. And we call those waves per second, and those are measured in hertz. The more cycles per second, the higher the pitch of a sound. Volume is determined by the height or the amplification of the wave. And the higher the amplification, the louder the sound. And the volume of something is measured in decibels. Here you can see that there are decibel ratings for some familiar sounds to you. A conversation at 3 feet is about 60 decibels, and the leaves rustling are about 40. Two people whispering is probably the hearing threshold. You can hear a watch ticking across the room. We talked about that absolute threshold of sound. That is considered 0 decibels, but you can still hear it. Pain starts at 140 decibels, and immediate hearing loss begins at about 85 decibels. So the ear is shaped to recognize sounds. The part of the ear that we think of, this part here behind my headphone that you obviously can't see, that is the ear that I think of when I think of an ear. But that is not what is actually doing the hearing. That part of the outer ear, called the pinna, is actually shaped to capture sound waves. And if you hold your ear or your hand behind your ear like this, you'll notice that you can actually hear much better because you're extending your ear out and capturing more sound waves. So the other two parts that we're going to be studying are the middle and the inner ear. The middle ear consists of the eardrum, or this membrane that vibrates when sounds hit it, and those vibrations transmit to the hammer, anvil, and stirrup, which are 3 tiny bones in the middle ear. And then they transmit that sound to the inner ear. And the only part of the inner ear we're going to be studying is the cochlea. And it's shaped like a conch shell. The cochlea is filled with fluid, and that fluid within the cochlea vibrates, which vibrates these little tiny cilia hairs in your ear. And that sends, when the hairs vibrate, that sends neuronic impulses to the brain via the auditory nerve. So also important to know. And how do we locate sound? We learn very on that if we use both of our ears at the same time, but if we hear more sound over here than we do over here, we look that direction to locate the sound. It seems simple and common sense, but we had to learn it at some point. And here is the human ear and the different parts that we talked about. So this is the pinna out here. Sound comes through the ear canal, vibrates against the eardrum, which does the vibrations through these hammer, anvil, and stirrup.
Which vibrates here against the membrane that's not shown, but then it does vibrate against the cochlea. And the hairs inside the cochlea vibrate and send impulses via the auditory nerve to the brain. And so that's all I have to tell you about the ear. Thank you for watching, and I'll see you in class.